Hello brothers and sisters, this is Mishako H, and in this video we're going to be discussing about variables. Variable is a basic unit of storage in a Java program. It is defined by combining an identifier, a type, and an optional initializer. Also, variables have a scope which defines their feasibility and a lifetime. Variables cannot be used before declaring them. The standard form for declaring a variable is writing the type followed by space, then identifier, and then equal sign, and the value you're going to assign to that variable. Optionally, you can just define it by type an identifier, and then later on you will pick the identifier and assign a value. That's later on in the program. So that's two ways to define a variable. The type refers to the name of a class or interface or Java's data types. For example, the data types we did, like the integer, the boolean, and the character. We will discuss class and interface types later, so do not worry about me mentioning them right now. The identifier is the name of the variable. For example, number, you can call your variable any name you want to, age, and so on and so forth. So when we combine the type and the name, or the type and the identifier, we get examples like int, age, boolean, test, and so on and so forth. For the first option, we initialize the variable by putting equal sign and a value, then close with a semicolon. In the second option, we only declare the variable, then in the second line we call the identifier and assign a value before closing with a semicolon. Remember, Java codes always terminate with a semicolon. Note the value must be compatible to the type. For instance, if the type is int, the value must be an int. A comma is used to separate multiple identifiers of same type when declaring more than one variable. For example, you can declare a variable by saying type and then put your identifier 1, comma, identifier 2, comma, identifier 3. If it's 3 items, then you can close it with a semicolon. As an example, you can have int ID, age, and position. For example, you have the ID of your student, you have the age, and you have the position or the class position. What position was he after an exam? So if all those three things are integers, then you can declare them in one line. Variables can also be initialized on declaration. For example, int ID is equals to 1, comma, age is equals to 25, comma, position is equals to 55, and then you end it with a semicolon. Now we have something called dynamic initialization. In the examples we've just seen, we used constants to initialize our variable. However, it's possible to initialize them dynamically with expression valid at the time of declaration. For example, if you're given the adjacent and opposite side of a right angle triangle, it's possible to find the hypotenuse using Pythagoras theorem. So you would possibly have three variables: your adjacent, your opposite, and your hypotenuse. So we can declare the first one as double adjacent is equals to 3.0, comma, opposite is equals to 4.0, and then end with a semicolon. We can decide to declare the hypotenuse as double hypotenuse is equals to math.sqrt, and then we have it in bracket adjacent times adjacent, which is like squaring the adjacent plus the opposite times opposite. So it's like the square root of adjacent square plus opposite square. That's the Pythagoras theorem, right? So as you can see, hypotenuse is initialized dynamically to the length of the hypotenuse as computed using Pythagoras theorem. Note the use of sqrt, which is a method or a Java's built-in method and a member of the math class. So you saw math.sqrt, so we called the method for finding the square root from the inbuilt math class in Java. Okay? The key point in dynamic initialization is that the initialization expression may use any element valid at the time of the initialization, including calls to methods, other variables, or literals. The next thing now we're going to do is the scope and lifetime of variables. A scope is defined by a block which begins with an open curly brace and ends by a closing curly brace. Okay? All the expressions we have done were defined within the main method or inside the block or scope of the main method. Most programming languages define two general categories of scope. The first one is global and the second one is local. In Java, these traditional scopes do not fit well with the Java's strict object-oriented model. While it's possible to create something that amounts to being a global scope, it is by far the exception, not the rule. So in Java, the two major scopes are those defined by a class and those defined by a method. Although I will show an example program to explain those defined by a class, I will not cover them in detail yet because I will show you after teaching you about classes. So right now we will see those defined by the methods, okay, because we are still yet to discuss about classes in detail. The scope defined by a method begins with its opening curly brace. However, if the method has parameters, they are included within the method's scope. I will teach about parameters and arguments in the upcoming videos as well, okay? So don't worry about that. But let us have a general view of them for the sake of understanding the concept of scope and lifetime of variables. As a general rule, variables declared inside a scope are not feasible or accessible to the code that is defined outside that scope. In this case, when you declare a variable within a scope, you're localizing that variable and protecting it from unauthorized access or modification. Scopes can be nested. For example, each time you create a block of code, you're creating a new nested scope. When this occurs, the outer scope encloses the inner scope. This means that objects declared in the outer scope will be visible to the code within the inner scope. However, the reverse is not true. Okay, like whatever is in the inner scope cannot be seen on the outside scope. As I mentioned earlier, variables should be declared before using them. Variables can be declared at any point in a block but are valid only after they are declared. Thus, if you define a variable at the start of a method, it is available to all the code within that method. Conversely, if you declare a variable at the end of the block, it is effectively useless because no code will have access to it. So you cannot use a variable that you have not declared. Variables are created when their scope is entered and destroyed when their scope is left, meaning that a variable will not hold its value once it has gone out of scope. Therefore, variables declared within the method will not hold their values between calls to that method. Also, a variable declared within a block will lose its value when the block is left. Hence, the lifetime of the variable is confined to its scope. If a variable declaration includes an initializer, then that variable will be reinitialized each time the block in which it is declared is entered. In the example program, we will use a for statement, which I do not want you to worry about because we will soon cover it, so just type along. Note that the for scope is entered and left every time it is incremented. That's the reason the output shows that for the 3 times the scope is entered, the value of y is 10, though it is set to 15 before exiting the loop. Although blocks can be nested, you cannot declare a variable to have the same name as one in an outside scope. An array is a group of like-typed variables that are referred to by a common name. We were to cover arrays together in this video covering variables, but I realized that they are dependent on control statements like the for loop, which we are yet to cover. So I will move the topic arrays to come after I teach you about the control statements. You also realize that we did not cover strings, which is part of data types. If you came from C and C++, where they are implemented as an array of characters, strings in Java are actually object types. Java implements strings as an object. Java includes extensive string handling capabilities that are both powerful and easy to use. I therefore left string for later use because I will gather them together with the string handling capabilities or capabilities. It depends on how you pronounce it. So thank you for watching my video tutorials on variables, and don't forget to like, subscribe, comment, and see you in the next video. Goodbye.